Everywhere you look, our world is becoming more electric. Cars, phones, homes, even entire cities are starting to run on batteries. But there's a problem. Today's lithium-ion batteries, the ones powering almost everything, weren't built for the future we're heading into. They're powerful, yes, but they're also fragile. They degrade, they overheat, they can even catch fire. And that's why scientists, engineers, and tech companies all over the world are racing toward one breakthrough that could change everything. Introducing solid-state batteries, the technology many believe will power the next generation of electric vehicles, portable gadgets, and renewable systems. Unlike traditional lithium-ion batteries that rely on a liquid electrolyte, solid-state batteries replace that liquid with a solid material. And this one change, it unlocks a new level of performance. For starters, solid-state batteries are far safer. No liquid means no leaking, no swelling, and a much lower risk of overheating or fires. Companies like Toyota and QuantumScape have shown that solid electrolytes stay stable even under extreme conditions. Second, they can store much more energy in the same space. That means longer lasting phones, lighter devices, and electric cars that can finally travel 800 to even 1000 kilometers on a single charge. Solid-state batteries could also charge in minutes instead of hours. QuantumScape's early tests showed charging from 0 to 80% in just 15 minutes. As the world shifts to renewable energy, we need better storage, batteries that last longer, charge faster, and won't burst into flames. Solid-state batteries offer exactly that. They're not just an upgrade, they're the future of how we power technology, transportation, and maybe even our entire energy grid. So today we're diving deep into this breakthrough technology. How do solid-state batteries work? Why are companies investing billions into developing them? And what challenges must be solved before these batteries power our world? Let's explore the science, the promise, and the road to making solid-state batteries a reality. This is the future of energy.
Hello everyone! Today I'm going to explain how solid-state batteries work in a simple way. Promise hindi to super technical, and I'll add konting Tagalog para mas relatable. So first, what exactly is a solid-state battery? Think of it as a modern, upgraded version of the batteries we use today. The big difference is, regular batteries use liquid inside, pero solid-state batteries use a solid material as their electrolyte. Yes, solid, para mas stable na version ng battery. Every battery has three main parts: anode, cathode, and electrolyte. The anode is like the starting point, the cathode is the ending point, and the electrolyte is the path where ions travel. In normal batteries, that path is liquid, and ions move through it like they're swimming. When ions move from the anode to the cathode, nagkakaroon ng power yung device mo. When you charge, the ions goes back. But in solid-state batteries, the electrolyte path is solid. Even if solid siya, ions can still move easily. Parang naglalakad sa hallway. Solid floor, pero smooth pa rin ang movement. So, while you're using your phone or device, ions travel through that solid material to the cathode, and that creates electricity. Pag nag-charge ka, balik sila sa anode. Same concept, but a better execution. Now, let's talk about why solid-state batteries are a big deal. Reason 1. Mas safe. No liquid means less chance of leaking or overheating. Mas chill. Less worry, hindi oops moment. Reason 2. Longer lifespan. Solid materials don't degrade as fast. Kung ang usual battery mabilis mapagod, solid state is more like kaya ko pa to. Reason 3. Faster charging. Some solid electrolytes let ions move faster, so mas mabilis ma-full charge. Reason 4. More energy in a smaller size. These batteries can store more power even without getting bigger. Perfect for electric cars, mas malayo ang kaya without stopping often. That's why a lot of companies today are really investing in solid-state technology. In the future, we might have phones with super long battery life, laptops that don't die during class, and electric cars that can travel farther than before. So, to keep it very simple, solid-state batteries move ions through a solid instead of liquid, making them safer, stronger, and more efficient. And that's how a solid-state batteries work. Simple, solid, and reliable. Thank you.
Application of solid-state batteries. Solid-state batteries replace the liquid electrolyte in lithium-ion batteries with a solid material. Because of this, they offer high energy density, better safety, longer lifespan, and faster charging. These advantages open many applications. First is electric vehicles. SSB are considered the future of EVs because they can provide longer driving range, charge much faster, reduce risk of battery fires, and handle more charge cycles. Second is consumer electronics. Solid-state batteries can make devices smaller and thinner, last longer per charge, safer, used in smartphones, laptops, tablets, and wearables. Third is energy storage systems. Great for renewable energy storage because they are more stable over long periods, able to operate in a wider temperature range, longer lifespan than lithium-ion. For application of that is solar farm storage, wind farm storage, and home energy storage systems. Next is medical devices, used for safety and reliability. For example is pacemakers, implantable medical devices, hearing aids, portable medical tools. Their long cycle life and high safety make them ideal. Next is aerospace and defense. Solid-state batteries can tolerate extreme temperatures and vibrations. For applications, satellites, drones, military equipment. Next is Internet of Things or IoT devices. SSB are compact and long-lasting, perfect for smart sensors, RFID devices, embedded systems, and smart home devices. Next is robotics. Robotics benefit from longer operation time, compact battery size, increased safety, higher power output. Applications, industrial robots, autonomous drones, and service robots.
Now let's talk about advantages. Why are they better? Number 1, safer. No flammable liquid equals no fire risk when damaged. Eliminates the possibility of fire and explosion. Number 2, more power. 50 to 100% more energy storage in the same space. Electric vehicles could achieve 500 to 600 plus miles range. Longer usage for all devices. Number 3 is fast charging. Full charge in just 10 to 15 minutes versus current 30 to 60 minutes. Similar convenience to refueling at a gas station. Number 4, longer lifespan. Lasts 2 to 3 times longer than current batteries. Potentially 20 plus years of use. Fewer replacement equals more savings in the long run. And then in the challenges, what are the problems? Number 1, hard to make. Creating perfect solid layer at mass scale is extremely difficult. Small imperfections can cause battery failure. Manufacturing process need to be perfect. Number 2, very expensive. Several times expensive than today's batteries. Current estimate shows 3 times or higher cost. Mass production need to bring costs down. Number 3 is temperature issues. Don't work well in cold weathers. Performance drops significantly in low temperatures. Big problem for countries with winter seasons. Number 4, still in development phase. Not commercially available yet for mass market. Wouldn't be widely available until late 2000s or early 2030s.
Hello everyone! Our topic is solid-state batteries. Take a look at your phone, your laptop, or think about the electric cars quietly taking over our roads. They all run on the same fundamental technology, lithium-ion batteries. They've been a revolution, but we're hitting their limits. We want safer, faster charging, and longer lasting energy. The next great leap isn't just an upgrade. It's a completely new chemistry. It's the solid state battery. What makes it so special? In traditional batteries, lithium ions move through a flammable liquid electrolyte. A solid state battery replaces the liquid with a solid material, a ceramic, glass, or polymer. This single change unlocks three momental advantage that promise to redefine our energy landscape. Potential development and impact. First, safety. Remove the flammable liquid and you drastically reduce the risk of fire and thermal runaway. This is huge, especially for large battery packs in electric vehicle. Second, energy density. The solid design allow us to use an anode made of pure lithium metal, which can store significantly more energy than the graphite anodes used today. What does that mean in real terms? It means an electric vehicle could see its driving range jump by 50% or more, potentially pushing single charge range toward 800 to 1,000 kilometers. This addresses the infamous range anxiety once and for all. And third, charging speed. Because the solid electrolyte is more stable, we can safely push more electricity into the battery at once. Researchers are achieving ultra-fast charging with the potential to recharge a car battery to 80% in as little as 10 to 15 minutes, a time comparable to filling up a gas tank. The market is anticipating this change. Expert project the solid state battery market to grow from around $100 million to well over $1 billion by 2032. Future outlook and conclusion. So, when will they be in your car? The timeline is aggressive but complex. While many manufacturers initially target the late 2020s, some are now suggesting an earlier, more modest rollout with widespread commercialization likely commencing between 2027 and 2030. The challenges are in manufacturing. Solid electrolytes are tricky to work with. They can be fragile, and ensuring perfect contact stuck between all the solid layers in a large-scale cell is a massive engineering hurdle. Researchers are also working hard to find materials that perform efficiently across a wide range of temperatures. However, the payoff is immense. Solid state batteries won't just improve electric vehicles. They'll transform consumer electronics with slimmer, longer lasting devices and revolutionize grid scale energy storage, making renewable energy resources like wind and solar more reliable. Solid state batteries are not just about a better car battery. They are about fundamental shift in how we store and use energy. They promise a safer, more efficient, and truly electrified future. The race is on, and the finish line is a world powered by this next generation technology.